I'd like to focus on a couple of linear applications, and for this lesson specifically something called a mixture problem. The idea is that you have two different solutions, and you are going to pour them together and determine something about the final mixture. So for our two solutions, we have 2 liters of a 10% acid solution, so that could be like one of your containers here. This is 2 liters and it is 10% acid. And then for the other one, okay, so it's also 2 liters, and this is 30% acid. If I were to mix these two together, what is the final concentration of that mixture? You could probably guess the answer to this one without even setting up an equation. I mean, if you think about it, the first one's 10%, the other one is 30%. I can already tell you the answer is not 40%. You wouldn't just add the two percentages. In fact, it should balance. The answer should be something between 10% and 30%. And I'm thinking that since I have equal amounts of both, that the answer should be right in the middle. It should be 20% acid. If for some reason I had 4 liters versus 2 liters, well then I guess that would pull the answer closer to 10%. Or if there was more of this stuff, the answer would be closer to 30%. But they're equal in amounts, so I'm thinking it's going to be right in the middle for the concentration. To verify this in equation, what we're going to do is set up two sides, where one is what we're mixing together, and on the other is what we end up with in terms of the total acid. So I wrote that out. I mean, basically something like this. The two things I pour together and what it equals at the very end. So in terms of what I mix with respect to the two solutions here, it's going to look like the following. I'm going to take 10% of 2 liters. This is the amount of acid in this container. If I take 10%, convert it to a decimal, and multiply by 2, that's the number of liters of acid in this one solution. Now when I say mix that in with this other one, I'm going to use the operation of addition. And to this, I'm going to add the amount of acid that is in this container. And that is going to be 30% of 2 liters. This is the amount of acid I get if I pour these two together. Now on the other side of my equation, what I end up with, well, it's going to only be one thing instead of two separate pieces, but it's going to be some percent times some amount. So it'll have this form, a percentage times an amount, but just one piece. So I think what we're going to need is a variable. Anytime that we solve an equation, you have to define a variable to work with. And so I'm going to go kind of like back to the beginning and say, I'm going to let x equal that final concentration of acid. Or maybe just final percent of the acid. I don't know what it is, but it's got to be something between 0 and 100%, and I'm thinking it's actually going to be 20 for my final answer. Whatever my final solution is, like I said, it's going to be a percent times an amount. It's going to be something of this form, percent times an amount. The percent is the thing I don't know, so I'm going to place it right here. That's the percent, and then here, it's the amount of stuff that we have if we pour these two things together. Well, if I have 2 liters in my first solution and 2 liters in the second solution, and I mix them together, you have 2 plus 2 liters, or just really 4 liters. Let's take a look at this whole thing. This is what I mixed together. It was 2 separate pieces because I had 2 separate solutions, and it was always the percent times the amount, the percent times the amount. What I end up with, it's just one piece, and it's still a percent times an amount. I needed a variable because I don't know what the percent is, but I do know the amount of stuff is going to be a total of 4 liters. I can now ignore the context of this problem and just solve this equation for x. I think it'll be pretty easy to do. So if I start multiplying and combining like terms, on the left, 0.1 times 2 is 0.2, 0.3 times 2 is 0.6, and on the right side, I have x times 4, which I'll write just as 4x. I can simplify the left side. 0.2 and 0.6 is 0.8. That's equal to 4x. To solve for x, I would divide both sides by 4. and 4 goes into 8 twice. There is one decimal remaining. That is 0.2 is equal to x. I have to convert that back into a percentage, and what do you know? That is 20%. That is the concentration of acid in the final mixture, and it is in fact what I expected. I wanted to look at this one first because you could probably guess the answer, but if you look at a more challenging problem, the equation that you're going to use is going to be identical. Perhaps the variable will be in a different place, but it'll always be two things, set equal to 1, and a percent times an amount. So one more example of a mixture problem, but just from a slightly different perspective. So what we have here is 2 liters of a 20% acid solution. That's our starting point. How many liters of an 80% acid solution must you mix in to obtain a 45% acid solution? So this is very different. What we're starting with is 2 liters of something that is 20%, but I want to end up with something that is 45% acid. And to do this, I'm going to pour in some number of liters of this 80% acid solution. So the reason this is different is because we have 2 liters of this 20%, but then over here it's like we have as much of this 80% acid solution that we need. I know it's 80%, I just don't really know how many liters I'm working with. I'm pouring this into here in order to increase this from 20% up to 45%. So in this question, x, the thing we're solving for, is the number of liters of the 80% solution. And the goal is, when I mix those two together, when I actually combine those two things, I want to have a 45% acid solution. All right, let's try to set this up in an equation. It seems like there's a lot that we don't know, but I think we'll be able to fill this in. All right, on the side where I'm mixing the two things together, it still is going to be the percent times the amount of stuff that you have, and I'm mixing in an 80% acid solution. It's just I don't know how much of it I have, but that's completely okay. You can just multiply that 0.8 times x, and this is the two things that I'm mixing together. It just happens to have a variable in it. On the other side of my equation, it still is going to be a percent times an amount. So, percent times an amount, but just one of those things. I know what the percent is. I want it to end up at 45%, so I'll put a 0.45 here. Now the amount of stuff that I have is going to be how much I mixed in from the two previous solutions. So I get 2 liters from this one, but then I don't know how many liters are from this one. That's completely okay, because you can add those two and place them here. You can say, well, this is just 2 plus x. And this is our equation. Just to step back and think about it, these are the two things I'm mixing together. This is what I end up with. The difference is the variable now is appearing on both sides of my equation. I believe this is true. My goal is to now just solve this thing for x. So let's do that. Okay, if I start simplifying the left, 0.2 times 2 is 0.4. And maybe I'll just write this next piece as 0.8x. Okay, I have to distribute in a 0.45 to both terms, and I get 0.9 plus 0.45x. I think I'm going to subtract the 0.4 from both sides, which gives me 0.8x is equal to 0.5 plus 0.45x. I'll now subtract the 0.45x from both sides, and I get 0.35x is equal to 0.5. To get my final answer, the number of liters that I need to pour in to get my 45% acid solution, I'm going to divide both sides by the number in front of x, which is 0.35. And I'm not going to do that in my head. I'm just going to go to my calculator and say, okay, I'm doing 0.5 divided by 0.35. And all right, I'm getting this decimal that seems to go on forever, so I'm just going to round my answer. Maybe I'll go to 2 decimal places, but I get x is equal to 1.43 liters. So the further out you go, the more accurate your answer will be, but you need approximately 1.43 liters of this stuff when mixed into here to take you down to a 45% acid solution.